Hello friends, thank you for watching this video. I am Mohamad and today we'll be exploring ASP.NET Core Dependency Injection. On this episode we'll be exploring and digging deep into dependency injection. How does it work and what is it and why do we need it? As well, what are the different types of DI lifetime, basically dependency injection lifetime, and when should we use every single one of them. So, what are we going to be covering today? First, we're going to be discussing what is dependency injection and how does it fit into the ASP.NET Core structure. Then we're going to be discussing the advantages and disadvantages of dependency injection. Then we're going to go deep into IoC containers, service lifetime, and then we're going to discuss the ingredients that we're going to be needing in order to build our code. And then we're going to jump deep into the source code and build our own ASP.NET Core application with dependency injection. As well, we're going to explore different features inside the code as well. As always, please comment your question in the comments down below, and please like, share and subscribe if you like this video. It will really help the channel. Now let's get started. So what does dependency injection means? In essence, dependency injection is a technique in which an object receives other object that it depends on. But what does that mean? Let us take a step back. Before understanding what does it mean in programming, let us first understanding what does it mean in general. So dependency or dependent means that we're relying on something for support. Like if we say we're relying too much on our computers, it means that we are dependent on them. And that meaning also carries to programming itself. So when we have an object and we say we are reliant on an object or dependent on an object, it means that we need that object in order for us to do our jobs or to do our work, or for that object basically to execute. So let us understand in a simple console application, what does object relying on another object mean? Let us create a very simple console application using the .NET new keyword. So .NET new console, we'll give it a name, sample app, and let's open this in Visual Studio Code. So let us open our program.cs, and inside our program.cs we're gonna be creating two classes. So the first class, we're gonna call it class A. So public class A, and basically we're gonna be creating two classes, classes A and class B, and basically we're gonna make sure that we're gonna require class B into class A, so class A will be dependent on class B. So let's see how that will work. So this is class A, and now let's create another class. We'll call it public class B. And inside the class B, basically we're gonna create a simple method. We're gonna make it public void, I'm gonna say print hello, and it's gonna take a simple string name. And then basically all we're gonna do is console.writeLine, and we're gonna say hello to the name. And here we're gonna be using string interpolation. If you don't know how to use string interpolation, I have another video which is gonna be linking up here on the upper right hand side. So once we have added this, now we have a class B with a method called print hello. Now we're gonna utilize class B inside the class A. So basically we're gonna get another method. We're gonna make it public void, and we're gonna call it get info. Just anything so we can see how this will work. And let's pass here a string name as well. And inside here basically we want to call the print hello inside the class B, so we need to initialize class B. So var b equal new b, and then basically b dot lowercase b dot print hello, and we're gonna pass the name that we have. As simple as that. And lastly, inside our console application, what we're gonna be doing, let's remove this, and basically var a equal new a, and a dot get info, we're gonna pass the name Mohamad. And now we're just gonna execute it. We're gonna open view, go to our terminal, and basically just type let's go to our application and type .NET build, make sure it builds successfully. Great. And now let's run it, .NET run, and now we can see hello Mohamad. And basically what we did here is we had two classes, class A and class B. And basically class A is dependent on class B to get this method in order for it to execute its work. So although we have called here class A in order for us to get the information, but class A is dependent on class B. And that's what it means when an object is depending on another object. So because here when we initiated an object of class A, we have utilized another object that came from class B in order for us to execute the print hello. So that's what we mean by an object depending on another object. So in summary, transferring the tasks of creating these objects and allocating them to someone else to handle them, that's what we call it dependency injection. So we don't really need to know about the intricate work of how the other object works. Basically, we're just calling objects that another objects might want to do, might want to utilize, and basically execute them. So that's what we call by dependency injection. Basically, a class will call the object that it needs, and it doesn't really care about where these objects came from, how they are initiated, how are they configured. All it cares about it needs an object of those classes. So here we can see inside the A and B classes, we have very deep integration between them. They are deeply linked because basically we cannot switch this B class easily if we want to, for example, execute a class C, for example, or class D. It was going to take a lot of work to do that. But with dependency injection, we'll be able to utilize and basically inject objects based on what we need. So that's what we're going to be exploring next. Now let's talk about the advantages and disadvantages of dependency injection. Dependency injection has a lot of advantages, but some of the main advantages that dependency injection provide is reduced code duplication, because basically we don't really care about initializing an object ourselves. We are relying on a service to initialize an object, which basically means that we are removing a lot of the code that it might cause any issues, and basically it allows us to reuse a lot of the code, and it will basically allow us to reduce the code duplication in initializing all of these objects. So that is one of the main advantages. Second is loose coupling. So as we said before inside our example, class A is deeply connected to class B. If we wanted to switch that functionality from class B to another class like class C, for example, we're gonna rewrite that class A integration, and it's gonna take a lot of time, and basically it means that we can have introduced a lot of errors inside our code by switching those. As well, it will make it very cumbersome for us to just delete the old code and add new code. It's not really the good way to do it. While we do loss coupling here, it means that we can actually inject the object that we need based on the configuration of our dependency injection. And that's a really powerful feature which we're going to be discussing when we actually create our own application and see how we can create our own classes and how we can inject them into our controller. As well, testability, because dependency injection is very loose coupled. We can basically mock a lot of the services that we want to utilize, and we can basically create a lot of the test-driven design, and basically we can create a lot of tests, and basically it allows us to test all of our application very easily and smoothly. As well, it would allow us to implement separation of concerns because of a lot of our major principles in object-oriented programming, like for example solid programming, unit of work, or any other. It requires a lot to have these three: enhanced testability, loose coupling, as well as code duplication, like the solid principle, for example. And basically dependency injection is one of the main principles in the solid principle, and here it also basically allows us to separate the concerns and the functionality that we want to implement, because basically when a class try to execute, or when a class is requiring another object to utilize and basically to run, it doesn't really care about how this object is configured. It doesn't really care who created this object, or basically where did it come from. All does it care about is it calls the IoC container, it asks for that object, and that object is provided for it. All of the configuration and all of the setting up of that object, the actual control does not really care about. So we can see here that how the separation of concerns actually come into place, because the concern of setting up that object is being handled by someone else, and the controller only need to be focusing on just taking that object and do whatever it needs to do with it. So with all of these advantages in dependency injection, what are the main disadvantages that comes with it? So first of all, it's complex. So if someone did not at all work with dependency injection before, it might appear a bit complex to work with. But the more that you try to practice with it and the more you try to illustrate how it works, it's much more easier for you to comprehend. Second, error management. Because dependency injection rely on the DI container and the objects basically are stacked on top of one each other, sometimes error management and basically error handling could be a bit hard to do. As well, traceability. Since, as we said before, it all relies on the DI container, which is a dependency injection container, to provide this object, tracing where is the errors coming from could be a bit hard. But again, if we implemented the right error management tools, it will be much more easier to do this traceability. So now let us create a web application and let's see how dependency injection works inside a web application. We're not going to be adding a lot of code at first, we're just going to examine how everything is working there. So let's go back to our terminal. And basically what we're going to be doing here is we're going to be creating a new web API application. So we're going to put .NET new web API -n, and we're going to call it sample API. This should take a few seconds to be completed, and then we're going to open it in Visual Studio Code, or actually it's already opened here in another folder. So let's go to that. And basically what we're going to be doing is we're going to go to the startup class and examine how everything is being set up here for us. So as soon as we actually created this project, this is all boilerplate code that has been provided for us by the .NET new keyword. Everything here is provided for us without actually us trying to do anything. So inside our startup class, we have the configure services method, and this configure services method is going to be the main method which is going to be responsible for creating and handling all of the dependency injection and the DI container. We're going to delve more deep into that, and we're going to be creating our own dependency injection, but for now let us examine how and the structure of our startup class. Second, we have the configure method, which basically is responsible for all of the middlewares. So if you don't really know what middlewares are, I have another video which I'm going to be linking on the upper right hand side where we discover more of a middleware. So ASP.NET Core provides a built-in dependency injection container. The framework takes the responsibility of creating and managing the lifetime of the dependency injection that it creates. Dependency injection is as we said, is configured by the configure services method inside the startup class, and basically inside this class we utilize all of the DIs and all of the configuration that we want to have there. So now let us see a built-in dependency injection that has been provided for us out of the box when we created this. Let's go to our controllers, and inside the weather controller we can see that we have a lot of stuff that is coming for us. But we can see here something that's happening, which is, first let us clean this a bit. We don't really need that. Before we delve more deep, let's delete this and just gonna do here return on OK. Return OK. And let's change this to iAction result. Okay, so as we see here, we have something called iLogger, which is basically the logger that is built into ASP.NET Core, and basically here we are initiating an iLogger for the controller that we are in. And then basically how are we initializing it? We're utilizing constructor injection. But you might think to yourself, okay, how is this being handled and how is this being created for us? Because basically what we're doing here is we are calling this controller, but we're not calling from anywhere, and we're not passing this argument for it from anywhere. Well, the logger here is being initialized through the dependency injection from ASP.NET Core. So ASP.NET Core, whenever it launches, there are certain classes that is automatically has the object ready for it, or initialize it directly inside its dependency inside its container, and automatically pass that object for us. So when we said here inside the startup class, when we said inside the configure services, we have the iService collection. And basically the iService collection here, what does it mean? It means that it has the collection of all of the services that we're going to be utilizing, and which inside these services, it's basically also the dependency injection services that we want. So inside this iService collection here that we have, is ASP.NET has certain classes that it provided for us and initialize it for us as soon as the application starts. So we don't really have to worry about those. So one of those services is the iLogger services, and we can see here we have initialized that, we have defined it here, and then we pass it through the constructor, and then it has automatically initialized because ASP.NET Core has taken care of it. But for us, for any other services that we want to utilize, we have to do this ourselves. ASP.NET Core will not be able to do it. It's only certain libraries or certain functionality that ASP.NET Core is able to do it for us. So now let us just do a simple logger here to see if it's working. So we can do logger dot log info information, and we're just gonna pass hello from logger. Now let's build and see. So we're gonna go back cd, and we're gonna go to sample API, and then we're gonna do .NET build. I think it's gonna fail. It succeeded, and now let's do just .NET run, and once it runs, basically it's gonna execute. Well, okay, we have an issue here. Let's see what is this issue. I think I have another service which is running on this port. Okay, let me stop the other service and let me try this again. Okay, it's running now on port 5001. Now let's open our web browser. 5000, and basically we don't have anything. Now we need to put the controller name, and the controller, I think it was weather forecast. Let's copy this and let's go back to the browser. And now we should receive an empty page because we returned an OK. And now let's go look at the logs, and we can see the logger has initiated, and we can see hello from logger, it's working. And now we can see that this service, which is the iLogger, has automatically injected for us by ASP.NET through constructor injection without us doing anything, because it's one of the built-in functionality that ASP.NET provide for us, which is great. Okay, so now we have taken a look of how dependency injection is inside our ASP.NET Core application, and how there is some certain services that ASP.NET Core has ready for us outside of the box. Let us see what are IoC containers and why do we need them. So what is IoC container? When a new object is required, its dependency needs to be assigned to a concrete class. This task can be delegated to a container. So let's say we needed the logger needs to be implemented in a certain class, and it needs to be set up somewhere. So where does this all set up? It's all being handled by the container. When an instance is in particular of type is requested to a container, it will inject the implementation that required by that type. Those implementation are defined in a set of mappings that can be easily changed. So inside the mappings that we're gonna have to add inside the startup class, we can actually see how are these instances that we want and the implementation that we want are mapped together. So let's say we have an interface and we have a class. We have the implementation of that interface. We have a class and a class. There's a lot of mappings that we can do. But for example here, the IoC container is basically the platform where we put all of the mappings, and whenever we request any of the services that we want, it basically goes to the IoC container. It checks, do I have an implementation for this interface or for this class? If it does, it will recreate an object for it and it will return it back. The container creates an object for the specified class, and also injects all of the dependency through its constructor, a property or a method at runtime, and dispose of all of that after at the appropriate time. So basically, once we have created an object and the dependency that we wanted is automatically injected inside our class, basically we can see through the constructor injection that we saw before with iLogger, that's where the initialization and the instance of that object that we wanted is being passed to, and then it passed to the method that are actually utilizing that. And once that is finished, it's being passed back, and the dependency container, the IoC container, which is a version of control container, is basically responsible to deleting it and basically removing it from memory. Although there is a lot of stuff that we can add, like iDisposable, in order to make sure that all of these objects are being removed correctly from our memory. So we can see here that we have three levels of or three different types of methods that the IoC container is responsible for. We have the register, we have the resolve, and we have the dispose. So what does the register mean? The register mean basically it's the mapping that we want to do between our interface and implementation, or a class and a class. So it determines which dependency to which it will instantiate itself when we actually request it. So let's say we have an iLogger interface and we have a logger implementation somewhere. Those are basically, we are mapping an interface to a class to our IoC container, and basically whenever we request iLogger, it will automatically know it's there. We're going to be creating our own mappings, and we're going to be basically know how to add them, how to register them, how is it going to be resolved, and basically how are they also being disposed. So what does resolve mean? Resolve mean that we don't really need to create our object manually. Why? Because as we said, once we request an interface, or basically once we request a service from the dependency injection from the IoC container, basically it will be automatically injected for us. So we don't really need to create the object ourselves, because once for example the constructor request from the dependency injection from the IoC container, it requests from it like, give me an object of the logger class, it is going to be the responsibility of the container to actually initiate that object for us. So we don't have to do this stuff manually. It's all based on the container. And lastly, dispose. So as we said before, whenever the lifetime of that object that we are utilized is finished and it's completed, we need to dispose it, and basically the IoC container is basically going to handle all of the dispose and basically remove it from our memory. I've been talking a lot of container, and I've been brushing through what mean IoC. IoC stands for inversion of control, and basically it's one of the main features of dependency injection, because we are delegating the control of creating that object to another service, and in our case right now it's the container. So IoC container means inversion of control container, and basically we are delegating the process of initializing, resolving, registering, disposing of our services to that container. And just wanted to make sure that when you read IoC, you know what it stands for and what does it mean when we say IoC container. There is a much more deeper meaning for it, but this is like a quick TLDR and quick overview of what IoC means. So before we jump into the code, let us discuss what is service lifetimes. So a service lifetime means how long will the service will live before it's being disposed of. So what we mean here, so we said that every time we request, for example, an object, or for example, let's say we request a service which is a logger, an object is provided. So a service lifetime mean here how much is that object gonna live, or how long is that object gonna live. We have three different options to determine the life longevity of an object, and it all depends on how we configure it inside our startup class. So the first way we can do it is transient, then we have singleton, then we have scope. What does transient mean, and singleton and scope? A transient lifetime means, so every time we request that object, every time I request that service, a new object is created for us automatically. So an object is never reused. So it's like having, for example, var obj equal new object. So every time we request that service, a new object is created for us, and the previous object is automatically being removed from memory. So that's what transient mean. For every request, or for every time we need that service, a new object is created for us. The second point is singleton. A singleton means, so as soon as the application is starting up, a new object is created for us, and that object is utilized every time we are calling that service. So let's say we have 6 endpoints, and within these 6 endpoints in our API we call that service 6 times. That same object is shared 6 times across the entire lifetime of that application. As soon as the application restarts, a new object is created, and then that object is long lived until that application restart again. So basically, for whenever we create an application, whenever the application starts, that object is created with it and is being shared across all of the different requests, across all of the different services. That object is, whenever we need it, it's available for us, and that's the same object being used and used again. Lastly, it's scope. So let's say we have 3 endpoints: a put, a get, and a post, for example. So we do a first call on the get. So as soon as we did that call on the get, a new object of the service is created for us. And let's say that get has dependency on other stuff, for example, and those dependency will need to use the same service. That object is shared with those dependencies. So basically that object is shared per request. So let's say we now do a post, another object is created for that request and then being shared for that specific request. It's not being shared with the previous request or the request that's gonna come afterwards. So per request we create an object for that service. So that way we are only that object has only a lifetime of that request. When the request is finished, that object is removed from memory and is deleted. So let's do a quick recap. Transient, every single time we require a service, a new object is created for us. Singleton, it means that whenever the application starts, we create an object, and that object is long-lived across the application until the application restarts again. And whenever we need it, it's the same object being used again and again and again. Scoped mean that for every request, we create an object for that service that is being utilized. And for every request, we recreate again and again and again for every request. Great, now let's see this in more details. So, let's say here we have three services. We have a logger service, we have a database service, and we have an email. So what we did is we put a logger service as a transient service, we put the database as a scope service, and we put the email service as a singleton service. So let's see here, we have a first request coming in, and within that request what we're doing is we're basically doing a get. So we're utilizing the logger. Since it's transient, a new object of that logger service has been created. And then because we need, for example, to connect to the database for any reason, a scoped service has been created for us. And then because we need to send a certain email, for example, a singleton service of that email has been created. So now we have three objects. The first object is a logger, the second object is a database, and the third object is an email. So as we can see here that we have T, which stands for transient, ST, which stands for scoped, and S for SI for singleton. But we have a number. So the number here we have added, it's for us to know how many times an object has been created from that service. So as we said, transient is basically an object is being created every time we need it. So, and because this get functionality here is dependent on other services, so, and those services basically require another logger, we can see that another instance of the logger service has been created, and a third service, third object of that logger service has been created. So now we have three objects for the logger inside the same request. So on the other hand, for the scoped service, which is for the database, once it has been created once, it can be reused again. So we can see we have SC1, which means that we have one and another one here. So we have the same object being utilized again and again on the same request. And lastly, we have the singleton. The singleton, as we said, it's on the lifetime of our application. So because this application has automatically started, an object of that service with the email service has been created for us. And you notice we don't have a number next to it, which means that this service here is only going to be created once across its lifetime. So it's being reused one here and once again here. So in total we have 1, 2, 3, 4, 5, 6, 5 services running at the same time. 3 of them belong to the logger because they are transient, and 5 objects are running at the same time. 3 of them belong to the logger service because they are transient, so every time we need them we create a new object. We have 1 for the database service because it's scoped and we are sharing it across the request, and the singleton is also 1 because we are sharing it across the lifetime of our application. Now let's see what happens if we do another call. So we did another call here, which is a post, for example, and within this post we're also utilizing the logger and the database and the email services. So as we know, because the logger service is a transient service, we had to create a new object now, which is what we expect. But for the database service, since it's scoped, we need to create a new object, because as we said, scoped lifetime, it means for every single request we create a new object for that service. And since the database is scoped, so we need to create a new object for it, and because now the first one is out of memory and we have completely removed it, we don't really need it anymore. So we have now a new object which is called SC2, which stands for the database, and lastly we have the SI. So the SI here, we can see it's a similar SI that we had from the previous request, because SI is lived across the application lifetime. It's not shared. So that's why it is shared. It's not regenerated every time. So that's why we are utilizing the same object that we have used for the previous request. So now we can see here that this post request has dependency on other services, and we can see because the logger is transient, we are initializing a new object. For the database, we are actually utilizing the same object that we have created for this request, and for the email, we're just utilizing the same one that we have created whenever the application has been whenever the application started to run. So we can see here the different lifetime and the different implementation that we have that comes into the dependency injection, and how everyone will benefit us. So for example, let's say if we are dealing with high sensitive data, it makes sense, for example, to have it as a transient, because we don't really want that object to be shared with different objects, with different service, with different requests. So we want to make sure as soon as we utilize it, it's out of memory, we deleted it, and we need to initialize it again with different configuration. For example, for a database service, it makes sense to have the scoped per request. So we don't really want to open different connection to the database. So one thing is, specifically if you're utilizing entity framework and unit of work, this will be really handy here. And lastly, the singleton, which is, for example, here with the email service, we don't really want to initialize it so many times. We can initialize it once and utilize it. And that's just an example. You can do whatever you want with them. There's just, I put them here, the logger, database, and email, for demonstration purposes only. So now that we have run through the theoretical part of a service lifetime, now let's jump deep into the code and see how everything works together. So let's go back to Visual Studio Code. And inside Visual Studio Code, what we're going to be doing here is we're going to be creating our own services, and we're going to be basically injecting them into our application and see how everything that we have discussed work. So on the root directory of our application, we're going to create a new folder, and we're going to call it services. And inside this services folder, we're going to create another folder, and we're going to call it interfaces. So inside this interfaces folder, we're going to create an interface called IOperation, which only has a code inside of it. So new interface, and this interface, we're going to call it IOperation. Great. So this, as we said, this operation interface is going to have a string type operation ID. And we're going to make it as a get only. And inside this folder, we're going to create 3 other interfaces: transient, IOperation transient, IOperation scoped, and IOperation singleton. And basically the way we named them like that, so we can actually inject every single one of these into a different lifetime, so we can see how they work, just for demonstration purposes. So inside the interface, we're going to create a new interface called IOperation transient, and it's actually gonna implement IOperation. Save. Now we're gonna create another interface called IOperation scoped, as well as gonna implement the IOperation. And lastly, we're gonna create a new interface. We're gonna call it IOperation singleton. Great. And this also is gonna implement the IOperation. Perfect. So once we have created these interfaces, we're going to be creating right now a class which is actually going to implement all of these 3 interfaces. And once it actually implement these 3 interfaces, after we implement these 3 interfaces, we're going to update our startup class so we can actually hook them up to our application. So inside the services folder, we're going to create a new class, and this class, we're going to call it operation. For some reason it's not working, so let's create a new file, and this file we'll call it operation.cs. and basically the first thing we need to do is, as always, to create a namespace. So let's copy this namespace, and then inside this namespace, we're gonna make it public class operation. And basically what we're gonna be doing is we're gonna implementing the 3 interfaces, which is IOperation scoped, IOperation singleton, and IOperation transient to this class, because basically all we're going to be doing is initializing a string of a GUID. So first of all, it's going to be IOperation scoped, and let's fix the references. Then we're going to put IOperation transient, and then IOperation singleton. Perfect. And now what we need to do is we need to actually implement this. So how are we going to implement it? First, by actually creating a constructor and implement it inside that constructor. So we're going to create a constructor. It's not going to take any parameters. And then here what we're going to be doing before that, let us create a new public string. We're going to call it operation ID because we need to implement it. And it's just going to be a get from here. And we're going to set the operation ID directly from the constructor. So it's going to be operation ID equal GUID.new GUID, and then basically we're going to be utilizing that to string to convert it to string. And then once we do that, we're going to utilize this to get the last 6 characters of this GUID. So let's fix this by using system. And why is this giving us so dot to string? Oh, we shouldn't put the dot here. Okay, great. So now this will give us actually the last 6 operations of the GUID. It's gonna be 2 out of 3. Yeah, let's see. Yeah, it's working now. So now that we have created the interfaces, we have created the class which is going to be implementing these 3 interfaces. How are we going to hook them up to our IoC container? It's very easy. As we said before, we're going to have to go to the startup class, and inside the startup class we're going to have to add them inside the configure services method. So inside the configure services, what we're going to be doing is we're going to be actually initializing the 3 of them, and every single one of them will have a lifetime based on their name. So services dot add a transient, and basically what we're gonna do, as we said, is gonna take an interface and implementation. So first we're gonna put the interface, which is gonna be I operation transient, and we're gonna implement it by the operation because it's actually implementing it. And then let's fix those references. Yes, and this one as well. Perfect. The next one is going to be services dot add scoped, and we're going to put I operation scoped, and then also we're going to utilize the operation. And lastly, we're going to put services dot add we put transient scope singleton, and put I operation, if I can type, operation singleton, and basically it's also gonna be operation. Okay, great. So now we have here, what we're doing is we're basically creating 3 services. Every service is basically hooked up to a unique interface. So first one is I operation transient, then we have I operation scoped, and then we have I operation singleton, and we have assigned the lifetime for every service based on its name. So for the transient service, we have the add transient. For the scoped, we have add scope, so on and so forth. And basically, because all of them are going to have the same implementation, which is we're getting the last GUID, we have done here is we have added the operation as an implementation. Great. Once we have done that, let's save this. And let's go back to our controller. So inside our controller here, what we're going to be doing is very simple. What we're going to be doing is we're going to be implementing these interfaces, and then we're going to actually call these interfaces here and see what happens. So how do we do that? Inside our weather forecast controller, we're going to put a private read only, and we're going to put I operation transient first, and then we're gonna put the transient up, and let's fix those references. And now we're gonna put another one. Private read only I operation scoped, we're gonna put scoped up. Again, lastly, private read only I operation, and it's gonna be not scoped, sorry, it's gonna be singleton, and we're gonna put singleton up. Great. So now what we're gonna be doing is, as we said, in order for us to utilize them, we're gonna have to use constructor injection. So how do we do that? It's very simple. let's take this, or we can do it manually. We can put I operation singleton. It's gonna put singleton op, I operation transient op, and lastly I operation scoped. It's gonna be scoped up. Great. So now what we're doing here, we're just telling the constructor that you need to actually have these three services ready for us. So once it has these services ready for us, we're gonna actually assign them to the services we have here, so we can actually utilize them across our class, our controller. So it's gonna be transient op, it's gonna be transient op, and then again scoped op, it's gonna equal to scoped op, and lastly it's gonna be singleton op equal singleton op. Perfect. Once we have done that, let's do a quick recap here. Because we have added this three services here, it will automatically be populated for us, and a new object will be created for us whenever we initialize this controller class, and whenever it hits the constructor, the objects will be automatically generated for us because the IoC container has taken care of it. So now once we have done that, let us just add logger information so we can see what's going on. So what we're gonna be doing is we're gonna adding some more logs. We can put logger dot log information, and what we're gonna be doing is first we're gonna just specify which service we're gonna be calling. So we're gonna put singleton, let's say utilize string interpolation, and if you don't know string interpolation, I have another video which we went through it into details, which I'm gonna link it in the upper right hand side. So we're gonna put for transient, and then basically what we're gonna be doing is we're gonna put underscore transient op dot get operation ID, and that's it. We're just gonna show that operation ID. Similarly, we're gonna do the rest, logger dot log information, and that's also using interpolation, and we're gonna put scoped, and basically we're gonna call underscore scoped op dot operation ID as well, and lastly for logger dot log information as well, we're gonna use string interpolation, and we're gonna put singleton, and we're gonna put underscore singleton dot operation ID. Great. So now we have done that. Or let's add the semicolon here. Once we have injected those services here, and we have added the loggers, let's save this. Let's open our terminal. So view terminal, and let us run it. So .NET build. First we're gonna build it to make sure it builds successfully, and then we're gonna run it. .NET run. Perfect. Now let's go back to our web browser, localhost 5000, and it will not show up. So what we need to do is we need to add the weather forecast, and now we're just receiving OK. But if we go back to Visual Studio Code, we can see here that we have the logger information showing up. So we see hello from logger, which is fine, and then we have the transient, which is we have the operation ID, the scoped, and the singleton. So basically this operation ID, it means that we have created an object and we have assigned any random string for that object, so we can actually monitor it. So we can see here from a single request we have got three different IDs, one for transient, one for scoped, one for singleton. Now let's refresh this and see what happened. What we need to expect is the singleton needs to be the same thing. Scoped and transient needs to be different. So let's go back to our web browser and let's refresh, and let's go back here and let's see what happened. So let's make this a bit bigger, and we can see here that actually we have another hello from logger. Perfect. We have singleton, which is going to be the same thing, 1D0D48, perfect. And we have scoped, which is different because the other one it was 055318, and the transient is also different because the last one it was 6A093, when now it has DCC, DC, EAC, etc. So we can see here that the actually singleton is actually working as it should, because we have one object being shared across different requests. But we cannot really now see how if we are actually recreating it for the scope or not, because we are actually utilizing once. So what we're going to be doing is we're going to be creating a new service, and through that service we're going to be utilizing the same services that we have currently, and we're going to be see if the scope is going to share that objects with them or not. So let's do that now. So what we're going to be doing is, let's make this a bit smaller. Let's stop the application. Inside the services folder, we're going to create a new class, and this class we're going to call it first service. It's going to be a very simple service. And basically here for this first service, what we're going to be doing is we're going to actually we're going to initialize those three different services that we wanted. So as always, the logger. So let's copy paste them directly from here. So let's copy these, because we want to create dependencies inside that first service. So let's initialize this here. Let's fix those references, and this needs to be first service, and let's fix this here. Perfect. Now let us create a constructor, and let's go back to the other services. Now let's copy paste these. So just saving a bit of time of typing, that's it. And this should be first service. Perfect. And now what we're going to be doing is we're just going to be creating a new method. So public method, actually void, sorry, and we're going to call it generate result. As simple as that. A service which require those services, and basically inside the generate result what we're going to be doing is we're just going to be logging information out. So it's going to be logger.log information, and basically we're going to use string interpolation again, and we're going to put, because we're going to call it first service, so put first service so we know which where it's coming from. And what we're going to be doing is we're going to put, this is going to be the transient one, and basically we're going to put underscore transient.operation ID, and let's put this at the end. So let's copy this as well and just modify the information 2 times. So let's fix this and this and this. So the second one is going to be scoped, and instead of transient op it's going to be scoped, and the last one is going to be singleton, and here it's going to be underscore singleton. Okay, great. Once we have done that, now you might think to yourself, okay, we have a new service. How are we going to be, and it's a class and doesn't have an interface, how are we going to be able to register that inside our startup class? Very simple. So the IoC container will also take a class and a class implementation. So a class. So how do we do that as well? Let's think about how do we want to inject this new service. Do we want it to be transient? Do we want it to be scoped? Do we want to be singleton? For the sake of this right now, we're just going to make it transient, because we want to actually regenerate it every time we use it. So we're going to put services dot add transient, and basically we called it first service, so we have to put first service and first service. Because of the IoC container, we are allowed to put the class and refer to the implementation as a class instead of an interface. Perfect. So once we have done that, the next step we need to do is we need to update our weather.conf forecast, because basically we're going to be building the dependency here. So what we're going to be doing here, we're going to add a private read only weather forecast. It's going to be first service. And then once we have done that, it's going to call it first service, and let's fix those references, And now here we're gonna put first service, and lastly first service equal first service. Perfect. We save this, and what we're gonna be doing here is, after we do this, we're gonna call that service. So as we said before inside the diagrams, let's see it again. So we're having a dependency inside our action of the controller. So we're calling dependencies here to see how they behaves. So let's call these dependency, and those dependency gonna be for the first service, and we're gonna put get result. That's it. And let's save this, and now let's run the application again. .NET run. And now let's go back to our web browser, and let's refresh this. And now let's go back to our web browser again, to our source code, and let's see what happened here. So the application ran perfectly, okay, and we called the endpoint, and the first thing we got is hello from logger, which is completely expected. And then we got the three services that we have, which is stand for this one, the transient, scoped, and singleton. So transient, it's E927, scoped is 7BB167, and the singleton is AF5A73, which is what we're expecting in new three different objects, because we are actually utilizing one request right now, so it makes sense. But right now, with the one we want to investigate is the scoped. So we want to see if that scoped object is being shared across the different across the same request or no. So let's see what happened when we called that dependency on the service, and we can see that transient is completely different, because we said transient is generate every time it's required. And let's look at the scoped. So the scoped here is 7BB167, and we can see it's the same one because it's being shared by the same request. Perfect. And lastly, we have the singleton, which is also the same, because we said the singleton is being shared whenever the application is running. So now let's try this again, but let's refresh. So let's go back to our web browser, and let's call this again, and let's see what happens here. So when we called it again, we have a new transient, of course, which is the 4AAB1B, which is fine. We have a new scoped, which is 7B3B12, which is completely different from the scope before. And then we have a new singleton, same singleton as before, because the singleton is shared across the lifetime of the application. Now let's see for the dependency what happens. Transient is new as expected, and we can see that the scope is also being shared per request. On the other hand, the singleton is the same thing as we have expected. Great. So now we have described the three different lifetimes that we have for this application. So the next thing that we're going to be doing and we're going to be covering is, let us create a new endpoint. So here we have get. So let's copy this, as simple as this, and we'll make this get all, and let's define a root for it. So we're gonna put a root, and we're gonna call it get all. Simple as that. Save, and now we have two endpoints. Now let's see what happened within these two endpoints. Perfect. Now let's go to our web browser and enter, and let's copy this, open a new tab, paste this, and we'll put get all. And let's see what happens. So we can see here, after we run the application, it's running. So the first time we run that, we got the hello from world, we have the transient, scoped, singleton, and we have here the transient is going to be different for that service. The scoped is the same, 7593, and the singleton is CE7. Perfect. Now let's go a bit down. Once we have refreshed and we have the get all, we can see that the transient, of course, is different. The scoped is different because it's different request, but the singleton is the same thing. And now let's see into the services. We can see that the transient is also different. The scope is shared with the previous one, which is 4E9, 5DC, and lastly the singleton is still the same. Great. So with this, we came to the end of this video. So let's do a quick summary. So dependency injection is basically in very simple terms is like we're requesting objects, and there's a service inside our code which provide these objects for us. And these objects have different lifetimes. They have a long-lived lifetime, which is going to be singleton with a lift whenever the application is running. We have one object that's being shared across different requests. There is a second lifetime, which is scoped, which is lived only per the request. So for example, for every single request that we do for the application, a new object is being created. And lastly, transient, every time we need this service, a new object is created. And all of this is managed by a unit of work, not unit of work, version of control IoC Container, and this IoC Container is responsible to manage all of the services. So that's the quick summary of this. If you have any questions, please write them down in the comments down below. Please like and share and subscribe if you like this video. It will really help the channel. Have a good day.